Okay, this is section 3.2, percent composition of compounds. So let's remind ourselves that a compound has two or more elements in it. So let's say you have an element A, and there's 3 atoms of A in a compound for every 2 atoms of B. That would count as a compound. So examples, you could have sodium chloride, you could have water, you could have hydrogen peroxide, you could have ammonia. These are all compounds. They all have more than one element in the chemical formula. There's no charges overall. It's a neutral substance. If the chemical formula has a charge, for example, so let me write down that these are all compounds. If there's a charge, for example, NH4 plus is similar to NH3, it's close to ammonia, just has an extra H plus in it. This would be called a polyatomic ion. We don't call it a compound. We call it a polyatomic ion, okay? So what the calculation we're going to do here, you could do for polyatomic ions, but generally they're done for compounds. So what we're going to do is we're going to calculate something called percent mass. And it's a very simple calculation. It's done for each element, and what you do is you take the number of atoms of a element, of one of the elements, and you multiply it by the atomic mass of the element. And then you divide that by the molecular mass. I'll put a little asterisk here that it could also be formula mass if it's ionic. Remember from the previous section that if we have a ionic compound, we would call it the formula mass. Now, to make it a percentage, what do you do to turn a ratio into a percentage? It means per 100, right? You multiply by 100%. Okay? Very simple. So let me just show you. Simple calculation. Let's try, for example, hydrogen peroxide. Okay, H2O2 is the chemical formula. Okay, so we're going to do 2 different elements. We're going to do percent hydrogen first. So we look up the atomic mass of hydrogen. It's 1.01, right? So let me write those over here. And then for oxygen is 16. These are the atomic mass in atomic mass units. So now in the chemical formula there's 2 hydrogens. So 2 times 1.01 AMU. And then we have to divide that by the molecular mass of this compound. Hydrogen and oxygen are both nonmetals, so this is a molecular substance. Okay? Well, how do we figure that out? Well, we're just going to add them up, right? So let's do the molecular mass. The molecular mass would be 2 times 1.01 plus 2 times 16. So that would be 34.02 AMU. Okay, so 2 times 1.01 divided by 34.02. Multiply that by 100. So what this does is essentially tells us what percentage of the total mass is due to hydrogen. So let's go ahead and calculate that. 2 times 1.01 divided by 34.02 times 100%, and you get 5.938. 5.938. I'm going to check that again. I just want to make sure. So 2 times 1.01 equals divided by 34.02 times 100. Oops, let's try it again. 2 times 1.01 divided by 34.02 times 100. There we go. You notice here, you have to be very, very careful with calculators because you get different numbers depending on how you're entering things in. So let's clear everything. 2 times 1.01, that's the hydrogen. Divide that by the total mass, the molecular mass, 34.02. Now multiplied by 100. There we go, 5.938. Percent hydrogen. Okay, so almost 6% of the total mass is due to hydrogen. You will note there's only 3 sig figs in here, so we should probably round this to, let's do it down here, 5.94% hydrogen. Now you have a way, if you wanted to know what the percent oxygen was, you'd have a couple different ways to do it. You could say, look, the 2 elements have to add up to 100% because the compound is made up of only hydrogen and oxygen. So you could take 100% and subtract the 5.94, and you would get, was that 94.06%? And that would be perfectly fine. You could even round that to 94.1%. Okay? Now, I'm going to show you a different way to do it, though. We're going to do it just like we did with the hydrogen. So let me make a little room over here. And that is, okay, percent oxygen would be, there's 2 oxygens in the chemical formula, so 2 times 16 divided by the molecular mass, times 100%. Okay, well, let me just do a little bit of the calculation there. The AMUs are going to cancel. Okay, so 32 over 34.02 times 100. 32 divided by 34.02 times 100, and you get 94.06. Okay, so 94%, again, you could round that based on, here it looks like we have 4 sig figs. So we'll go ahead and use that. So based on this data, it looks like it's around 94% oxygen. That means that if you were to weigh one of these molecules and kind of figure out how much of this molecule's mass is due to hydrogen, it's roughly 6% hydrogen and 94% oxygen. Okay? Try the practice problem.